Welcome back to Turning Turing. Today we'll be discussing the first practice problem on sorting. We'll try to cement our intuition and understanding of the concept through this problem. We'll also discuss the library function available by default in C++ for sorting, since more than 90 percentiles will be using the library method. We'll try to understand the algo used in the library method along with the type complexity of it. The question that we'll be discussing today is to minimize the maximum pair sum of array. This is Leetcode problem 1877. We'll be given an integer array of size n. The size will always be even, so we can make n by 2 pairs from an array without using any element more than once. Our job is to make a combination where the maximum sum out of all the pairs in this combination is smaller than the maximum sum for any other combination. Let's first try to find a solution for the problem and then see how sorting can help. So let's take an example array. What is the smallest sum that you can make in an array? You can take the smallest element and the second smallest element, and the sum of these two elements will be the smallest sum. So 2 plus 3 is going to be your smallest sum. And what is the largest sum that you can make? Obviously the sum of the largest element and the second largest element, which is 4 plus 8. So you can see that in order to keep the sum optimum, we need to balance the two elements we are picking in a pair. Let's consider the smallest element. What would be the best partner for the smallest element? The largest element that has not been picked yet. Why is that? Because if you don't consume the largest element now, it will pair with some bigger element in the future, and this will just increase the maximum sum. For example, let's consider an array 1, 7, 8 and 9. Now what should we pair with 1? 9 obviously. So the sum for 9 plus 1 is 10, which leaves 7 and 8, and the sum for 7 and 8 is 15. So the maximum sum for this particular combination is 15. Let's see what were the other alternatives. If we would have picked 7 with 1, then 1 plus 7 would have been 8, and the remaining two elements 8 and 9 would have been paired together, and the sum for 8 plus 9 would have been 17. So the maximum sum for this combination would have been 17. And let's say that we picked 8 to pair with 1. So 8 plus 1 would give you 9, and the remaining elements would be 7 and 9. So this pair would give you a sum of 16, and the maximum sum for this combination would have been 16. So you can easily see that we have the smallest sum in the case where we paired the largest and the smallest element. And it actually makes sense that we should always pair the smallest and the largest remaining elements at any given point, because if we are not picking the largest element with the smallest element right now, that largest element will be paired with another element in the future which will be greater than the smallest element, and that would just increase your sum. Now how does sorting come into play? To find the smallest and the largest of the remaining array efficiently, we can sort the array. You can see that this array is already sorted. So picking the largest and the smallest element is very easy. Smallest element will be at the start of the remaining array, and the largest element will be at the end of the remaining array. Once you have used these two elements, you moved one step forward from both the sides. Now wherever your pointer is at the end and the starting, that are basically the largest and the smallest remaining elements. So let's quickly go through the code for the problem. So our problem actually stated that we had to find the minimum maximum sum that we can get. So it was not actually identifying the combination, but returning the value of the minimum maximum sum that we can get. So we have defined a method minPairSum, which is going to return the answer, and the answer is going to be integer. As we have already discussed, we'll sort the array so that we can easily pick the smallest and the largest element of the remaining array. And we've kept a maximum with which we are going to store the answer for our problem. Now, as we discussed, in the sorted array, we'll keep two pointers. One will represent the smallest element, and the second will represent the largest remaining element. So now the largest element, since this array is sorted, the smallest element will be at 0th index, and the largest element will be at the last index. So we've initialize these pointers, I representing the smallest starting from 0 and j representing the largest starting from the last index. Now what we do is we keep moving both these pointers one step in every iteration. So the pointer representing the smallest element will move one step forward every time, and the pointer representing the largest element will move backwards one step in every iteration. And since this is an even sized array, whenever these two becomes equal, that represents that no element is left to pair. So we've put a while condition. We'll run this while condition till I is less than j, and when I is equal to j minus 1, that exactly represents the situation where only two elements are left. Now we'll pick the smallest and the largest element of the remaining array. We'll take their sum, and if the sum is greater than the maximum sum that we have found till now, we'll just replace the maximum sum with the new value, and we'll move I pointer by 1 and we'll move j pointer by 1 backwards in every iteration, and at the end of all the iterations we'll have the answer stored in maximum sum, so we'll just return maximum sum from here. Now, before discussing the time complexity of the solution, let's discuss the library sort method that we have used in our solution. The library sort method is a combination of insertion, quick, and heap sort. The particular algorithm is selected based on certain conditions. So as you know, the best case complexity of insertion sort can be lower if the whole array is almost sorted. The time complexity of quick sort can be lower based on the pivot that you're selecting. So the algorithm is selected based on which will be the most efficient for the given array. The time complexity for the library method on average is big O of n log n. In case you use a different programming language and use the library methods, make sure you have an idea of what's happening behind the scenes and what is the average and worst case time complexity of the method. This will make sure that you don't make logical errors and not go wrong while calculating the time complexity. Now, discussing the time complexity of our solution, we have n log n time complexity being offered by the sort method, and the while loop basically runs for n by 2 times because we are moving I and j by one step every time, so they'll meet in the middle, and when they meet we end our loop. So basically it's running for n by 2 times if n are the total number of elements, and we are doing 4 operations within each iterations. So the time complexity for this while loop is basically big O of n. So the total time complexity is n log n plus n, which is essentially n log n. So the time complexity for our solution is big O of n log n. Space complexity is obviously big O of 1. Hope you understood the intuition behind the solution and how sorting can be used in a solution. In case of doubts or feedback, feel free to use the comment section below. See you in the next video. Till then, take care and keep learning.